And we're going to start with Chapter 1, Section 1. And we're going to introduce the concept of an equation and an expression. We're going to talk about the difference between an equation and an expression, and then we're going to look at the three types of equations. And then we'll solve equations. So an equation has an equal sign, and it can be solved. It can be solved for a variable. That's a little bit too bright. It's almost hard to get it just right. Okay. So an equation, it has an equal sign, and it can be solved. So here are some examples. (5x plus 3 equals negative 2). Okay, so this is an example of an equation. We can solve this equation, right?
Yes.
Yep, and we can move that 3 over. Remember opposites, we move them over. And that gives you then 5x equals a negative 5. We divide it by 5. Okay, and that allows us to solve it. And that gives us now x equals negative 1. So that's an equation. Okay, an equation, it has an equal sign. We are able to algebraically solve it and get an answer. And there are three types. And we're going to discuss each type in detail here later on. This is called conditional. It's called conditional because we have an answer, a condition that makes it work. But this is an equation because we have an equal sign. An expression has no equal sign. So an expression has no equal sign, and it cannot be solved. So an equation has an equal sign, an expression does not. We don't really work a lot with expressions in this course, but once in a while we have them. Now, you can't solve them, but what you can do is you can combine. So here's an example of an expression. 5x plus 6 minus 2x plus 4. Okay, so this is an example of an expression. We do not have an equal sign, so we cannot solve it for x. The only thing that we can do is combine like terms together. So there's no equal sign, but we can combine a 5x and a negative 2x. That makes it a 3x. Yep. And a 6 and a 4 makes it a 10. So that's as far as we can go. We can't solve it because we do not have an equal sign. So let's now go ahead and talk about the three types of equations. We're not really going to focus much on expressions. Expressions are one of those things we really don't do a lot of. In mathematics, we want to be able to solve things. Once in a while, again, we do have expressions, but most of the time it's going to be equations. And there are three basic types of equations. And so the first one that we're going to look at is a conditional equation. And a conditional equation, it can be solved for a number, solved for an answer. And we'll just say solve for a numerical value. And that just means we're able to solve it, and we're able to get something like x equals 5 or 4, something like that. Conditional just means there's a condition that makes it work. So here's an example of a conditional equation. How about we have 3x plus 4 equals 9x minus 12. So this is a very simple to solve conditional equation. And what do we want to do? We want to solve it. We have an equal sign. So when we solve equations, what do we try to do? And our goal is going to be, we get the variable on the left-hand side, everything else on the right-hand side. You can do it in multiple steps, or you can do a lot of steps at once. Either way, you just want to take your time and make sure you don't make mistakes. Since we're just kind of reviewing things, I'm going to go through it each step one at a time. So the first thing I would do is I would move that 9x over. Now, right now the 9x is positive, so to move it to the left, to join the 3x, we have to use subtraction. So move that 9x over, and then we have 3 minus 9. Okay, the minus 9 is bigger than 3, so our answer is going to be a minus then 6. Signs are different. 9 minus 3 is 6. 9's got the larger, 9's the larger number with the negative, so my answer is a minus 6 there. Then we'll bring down that plus 4, and that equals a negative 12. And again, you can do multiple steps at once. I'm doing it one at a time for a few of these just so we kind of review things and remember how it works. Next step, what do? We move that 4 over with subtraction. And then that gives you then a minus 6x equals, we've got minus 12, minus 4, they're the same, they go together. And that makes it then a minus 16. Next step, we divide by a negative 6, and we need to reduce. So the left-hand side is now x by itself. And we want to try to reduce this down as much as we can. Negative and negative. Here, it's going to make it positive. Negative 16 divided by negative 6. Well, these both have a 2 in common. So we can reduce that down. And that's going to then be 8 over 3. And that would be your answer there. Negative and negative makes it positive. And that's going to be your final answer. And this is called conditional. Now, why is it called conditional? It's called conditional because we were able to solve it for a numerical value.
Do you care if we use improper fractions, proper fractions?
Normally we'll just use, unless it specifically states otherwise, we're going to use improper fractions like this. Okay. You really want to kind of stay away from decimals unless the question already has decimals in it. So if it's an application and they use decimals, you can use decimals. Otherwise, we'll just keep the fractions. And the only time we really use mixed fractions is when we're working some kind of application and maybe we want to turn it into something that we can use. So maybe we would want to take like, let's say, how about we have 9/4? Well, I don't really want to say I want 9/4 buckets of water. I could convert that into 2 1/4 cup or buckets of water, something like that. Okay, so the only time you'd want to use a mixed fraction is if it's some kind of application, and that's very, very rare. Normally, we use improper fractions. Yep, you're welcome. So that's a conditional equation, and 90% of your equations are going to be conditional. The other two types we see once in a while, but not as often. And they are the identity and the contradiction. So let's start off with the identity. And when we talk about the identity, we're talking about the sides being the same. Okay? So the sides are going to be the same. And how I remember it, and I remember identity, is I think of identical twins. All right, identical twins are the same, right? So that means when we work out an equation, if the sides are the same, it's called an identity. So the sides are going to be the same. Now, they may not look the same at the very beginning, but after doing some algebra, they may become the same. So here's an example of an identity. How about we have 5 times x plus 2 in parentheses equals, how about 4x, let's say minus 5 plus x plus 15. So right now, what we're going to do is we're going to try to work on solving this out. And first thing we want to do is we want to do each side separately. And always try to get rid of your parentheses. So we can get rid of that parentheses by distributing that 5 through. So the distributor will push through that 5. And that's going to then leave me with 5x plus 10. Right? Okay. And what about the right-hand side? Well, on the right-hand side, we're going to combine like terms together. So 4x and an x, that makes it 5x. Minus 5 plus 15, that makes it 10. And now we can look at them, and we can see that the sides are the same. So that makes it an identity. And the solution set for your identity is going to be all real numbers. And so what that basically means is whatever number I plug in, the sides are going to be the same. So let's look at this one quickly, and let's just plug in some different numbers, and you're going to see that they are the same. If I plug in for x, let's say x equals 3. If I use 3, what would you have? 5 times 3 is 15, plus 10 is 25. We'll look at the other side. The other side is also 25, right? If I use 0, what would you get? That would cancel 10. That would cancel 10, right? They're the same. So an identity means no matter what number I plug in, the sides are going to be the same all the time. Now the opposite of that is going to be a contradiction. And a contradiction is a false statement. So that's our next and final type of equation, is a contradiction. Okay, so that's going to be a false statement, contradiction. Now, how I remember contradiction is I just think of, okay, I go to court. And let's say I'm at a trial, and the defense says, you just gave contradictory testimony. And what does that mean if you gave contradictory testimony? You lied, right? You gave a false statement. So that's the way I remember it, is I just think of giving contradictory testimony in a court of law. Okay, that means they accuse you of lying, you gave a false statement. And that's a contradiction. Now in a contradiction, what's going to happen is the variables are going to disappear, and you're going to be left with something that will not and cannot work. So here's an example of a contradiction. How about 3x plus 9 equals 3 times x minus 4. And I'm trying to keep them very simple right now, just so you can see the 3 basic types. Here in a moment, I'm going to give you more difficult questions to work through. Some of them will have decimals, some of them have fractions. But right now we're keeping it simple so you see the 3 types. Now this one's going to be a contradiction because if I distribute that 3 through, on the right hand side, then what am I left with? I'm left with 3x plus 9 equals now 3x minus 12, right?